Welcome to section R7. We're going to be talking about solving rational equations. Now we're going to see a couple of different types. The first type we're going to see is a proportion. Fraction equals a fraction. The way we solve those is we cross multiply. X times 5, 5x. 2 times 8 is 16. So divide both sides by 5. X equals 16 over 5. And there's our answer. Now, another type of question you might see is where we have more than two fractions. Here, what we can do is get rid of the fractions. Remember, fractions represent division. And to undo division, you can multiply. So what we're going to do is we're going to multiply everything by the least common denominator. Now, to think about this, we have our denominator of 2, we've got a 4, and we've got an 8. Now, 2 is just the 2. 4 is the same as 2 times 2. And 8 is the same as 2 times 2 times 2. So for our LCD, we need to account for a 2. Now that accounts for this one, and this one. So they're all accounted for, those first 2's. We need another 2 for this one and for this one. So another 2, that accounts for those. And we still have one more 2 remaining. Another 2, that's accounted for. So our LCD, 2 times 2 times 2 is 8. So we're going to multiply each term by 8. Remember, in algebra, as long as we do it to everything, everything still stays in balance. Now I'm going to write this out. 8 times 3 over 2x. So that's the same as 8 over 1 times 3 over 2x plus 8 over 1 times 1 over 4 equals 8 over 1 times 5 over 8. Always simplify before you multiply. 8 on top, 2 on the bottom. They're both divisible by 2. The 2 becomes a 1. 8 becomes a 4. So it's 4 times 3x, which is 12x. 8 on top, 4 on the bottom. The 4 becomes a 1. 8 becomes a 2, so it becomes plus 2. Equals, the 8's cancel, 5. So we get 12x plus 2 equals 5. Subtract 2 from both sides. 12x equals 3. Divide both sides by 12, and we get x equals 1/4. And there's our answer. We got rid of all the fractions. Now, a problem like number 3. It's a proportion, cross multiply. So I'm going to show my work. 7 times 2x minus 10 equals 11 times x minus 2. So we distribute, we get 14x minus 70 equals 11x minus 22. So to isolate, we can subtract 11x from both sides. At the same time, we can also add 70 to both sides. So we get 3x equals 48. Divide both sides by 3, x equals 16. And one of the things we want to make sure of is that our value for x won't cause division by 0. If we put 16 in place of x, we're not going to have division by 0. This is a valid solution. Now, for problem number 4, once again, it's a proportion we cross multiply. You get 2 times the quantity of x minus 1 equals x squared minus x. So 2x minus 2 equals x squared minus x. It's a quadratic. We have to get it equal to 0. Subtract 2x from both sides. And we can add 2 to both sides. So 0 equals x squared minus 3x plus 2. And this quadratic is factorable. So when you factor that quadratic, you get x and x. To multiply to 2 and add to negative 3, we're going to have a minus 2 and a minus 1. Now that it's factored, set x minus 2 equals 0, x minus 1 equal to 0, so x equals 2 and x equals 1. We have to talk about extraneous solutions. Let's check this. Make sure they're both valid. 2 over 2 squared minus 2 equals 1 over 2 minus 1. So it's 2 over 4 minus 2 equals 1 over 1. So it's 2 over 2 equals 1 over 1. 1 equals 1. That's valid. Now let's check the 1. So we have 2 over 1 squared minus 1 equals 1 over 1 minus 1. So it's 2 over 1 minus 1 equals 1 over 0. We cannot divide by 0. As soon as I see that, I'm not going to check it any further. I know my 1 is extraneous. It's causing division by 0. It's extraneous. We throw it out. A question like number 5 now. We have more than a proportion. So what we can do is we can multiply everything by the LCD. The LCD here, we have the 2 we have to account for and also the x. That takes care of that one and that one. So our common denominator is 2x. We're going to multiply each term by 2x. So I'm going to write this out again. It's 2x times 4 over x. Put that 2x over 1. Plus 2x over 1 times 5 over 2 equals 2x over 1 times negative 11 over x. So you can see x on top and x on the bottom cancel. We're left with 2 times 4, which is 8. 2 on top, 2 on the bottom. We're left with x times 5, which is 5x, equals x on top, x on the bottom cancel, negative 22. No more fractions. Just a regular Algebra 1 problem. We subtract 8 from both sides. 5x equals negative 30. Divide both sides by 5. X equals negative 6. If I put a negative 6 in there, it's not going to cause division by 0. This is a valid solution. Number 6, remember that 7 is just over 1. So we can get rid of the fractions by multiplying by the LCD, which is x minus 2. I'm going to multiply x minus 2 all 3 terms. I'll write it out again. It's x minus 2 over 1 times 5x over x minus 2 equals x minus 2 over 1 times 7 over 1, don't forget about that, plus x minus 2 over 1 times 10 over x minus 2. The x minus 2 on the top and the bottom cancel out, so we're left with 5x equals. Nothing cancels here, so distribute the x minus 2 to 7. 7x minus 14 equals, here the x minus 2's cancel. Oh, sorry, that's plus. So 5x equals 7x minus 14, and it's plus 10. 5x equals 7x minus 4. Subtract 7x from both sides. You get negative 2x equals negative 4. Divide both sides by 2. X equals, divide both sides by negative 2. X equals positive 2. Once again, check for extraneous. Now, looking at this, I have 5 times 2 over 2 minus 2 equals 7 plus 10 over 2 minus 2. So we have 10 over 0. As soon as I see that, we can't have division by 0. We only had one solution, and it didn't work. So here our actual answer is no solution. There's no solution. Our only answer was invalid. Let's do one more, problem number 7 on the next page. Now, before I look for my LCD, I'm going to do a little bit of factoring. X squared minus 1 is the same as x plus 1, x minus 1. So for my LCD, I need an x plus 1. That takes care of this one and this one. I need an x minus 1. That takes care of this one. And I also need a 3. That takes care of this one. Oh, sorry. I don't need a 3 because that's not in the denominator. Sorry about that. So we're going to multiply everything by x plus 1, x minus 1. Once, twice, 3 times. So I'm going to write this out so we can see. So we have x plus 1 times x minus 1 over 1 times 4x plus 1 over x plus 1 equals x plus 1 times x minus 1 over over 1 times 12 over x plus 1, x minus 1, plus 3 times x plus 1, x minus 1 over 1. All right, so simplify before we multiply. The x plus 1's cancel. So we have 4x plus 1 times x minus 1. So we multiply, we get 4x squared plus x minus 4x minus 1 equals 12 times x plus 1 times x minus 1. Now we know x plus 1 times x minus 1, it's x. So it's 12 times x squared minus 1 plus 3. Oh, excuse me. Sorry. The x plus 1 and x minus 1 cancel. All we're left with is a 12. Easier than I just made it. And now it's plus 3 times, and we know x plus 1, x minus 1 is x squared minus 1. So we combine. We get 4x squared minus 3x minus 1 equals 12 plus 3x squared minus 3. 4x squared minus 3x minus 1 equals 3x squared plus 9. To quadratic, I want to get everything onto the left-hand side. So we're going to subtract 3x squared. I'm also going to subtract a 9. So that gives me x squared minus 3x minus 10 equals 0. So when I factor, I get x minus 5 and x plus 2. So my solutions, x equals 5 and x equals negative 2. Looking at those, if I put a 5 in the denominator, it doesn't cause division by 0 here, here, or here. So that one's fine. If I put a negative 2, doesn't cause division by 0 here, here, or here. So they're both valid solutions. I will be assigning a couple problems from this packet, and I will see you in the next video. Thank you and have a good day.